The future of the universe is both amazing and terrifying. Everything you see in this video is true. From Africa splitting open and an entire sea turning into a desert to the night sky itself going dark, one galaxy at a time. We're going to miss it all. I'm going to take you on a journey to see what the Earth will look like billions of years from now and what will create the final light to ever shine in the cosmos. And it all starts with something that's been sitting over your head your entire life. If you live in the Northern Hemisphere, you're probably familiar with Polaris, the famous North Star. We see it as a fixed point sitting right at the top of the sky, never moving at all. And yet, over the next 12,000 years, this is what is actually going to happen. Polaris will drift away from the Northern Pole, and about 11,700 years from now, a new star will take its place. Vega. The stars themselves aren't really moving. They're so far away that they basically never shift relative to us. It's the Earth that's wobbling like this. Over 26,000 years, we swing all the way around in this circular motion, and as we do, our North Star changes. Even today, Polaris isn't perfectly north. Zoom right in and it traces a tiny circle, sitting just 0.46 degrees off true north. It'll officially leave the northern point in around the year 2400, and then for the next 800 years, the northern hemisphere will have no famous North Star at all. But that's not that bad. I mean, the southern hemisphere lives like this right now. Down south, there's no bright pole star. For centuries, sailors navigated using the North Star. So what did seafarers in the south do? Well, they looked to the Southern Cross, extended its long axis like this, lined it up with this line drawn from the two bright pointer stars, and right there is the southern celestial pole. So we'll lose our North Star in the next few hundred years, but eventually Vega will take its crown. Our sky is rearranging itself constantly, but the ground beneath us is constantly changing too. And in one particular spot, something brand new is about to rise up out of the sea. This is modern-day Hawaii, an archipelago of 137 islands and atolls. These are the 8 main ones. Now, just off the coast of the big island, there's nothing. But Hawaii's next island is already here. You just can't see it yet. Almost a kilometer below the surface, there's a mountain, and it's growing. This is Kameehua Kanaloa. Islands like these form when a plume of heat deep in the Earth's mantle rises up through the tectonic plates as it drifts. The Pacific plate is moving about 8 centimeters per year, so like a conveyor belt, one island after another rises up out of the ocean. And this is the newest one, the youngest volcano in the chain. Its summit is still 975 meters underwater, so to become a real island, it has to grow by almost a full kilometer. That's taller than the Burj Khalifa. That growth should take around 100,000 years. Right now, it's fairly calm, just lava oozing out of that deep ocean. But as it nears the surface, things get violent. You'd see a column of black ash 9 to 10 kilometers high, filled with lightning. And even breaking the surface isn't enough to survive. In 1963, just off the coast of Iceland, a brand new island called Surtsey began rising out of the sea. It only made it because lava sealed the vent on the ocean floor and wrapped it in a hard rock, a kind of armor. 3 siblings tried to emerge alongside it, but without that armor, the ocean simply tore all 3 back down within weeks. So 100,000 years from now, Hawaii's 9th island will finally break through, and no one alive today will ever get to stand on its shores. For over a decade, astronomers had a nickname for this star, a Death Star. They thought it was a loaded gun aimed right at the Earth. It's called WR104, about 8,400 light years away. It's a rare type called a Wolf-Rayet, locked in an orbital dance with a hot companion star. Wolf-Rayets constantly blast out high-speed energetic winds. As the 2 stars orbit each other, those winds smash together, throwing out superheated material in every direction. And that leaves behind a glowing coil of dust, and we can use that coil to clock how fast they're orbiting. 1 full rotation every 241 days. One day, this star is going to go supernova. And back in 2008, observations suggested its pole was pointed almost directly at us. If a star like this went supernova and it fired a gamma ray burst, a beam of the most intense radiation in the universe straight down its pole at us, that's a very bad day for our atmosphere. It could completely strip away the ozone layer and trigger a mass extinction. But luckily, follow-up observations show that we are seeing it more side-on. The gamma ray burst would miss us. We'll be fine, but it still will go off, and when it does, it'll shine brighter than Jupiter despite being over 8,000 light years away. We'll see it glowing in the sky for months. And here's the catch. We have no idea when this will happen. It could be tens of thousands or hundreds of thousands of years from now, but either way, you and I will definitely miss it. You've probably noticed a few of these beautiful 3D printed models behind me, like this one of JWST, and I was only able to make these because of today's sponsor, Bambu Lab. If you know anything about 3D printing, then I'm sure you've heard of Bambu Lab before. They often get referred to as the Apple of 3D printing, and honestly, I get it. I printed all of these on the H2C, one of their flagship production machines, and the whole process could not have been easier. It took me around 30 minutes to set it up, and then I could simply use the Bambu Handy app to start printing projects. Bambu is known for having seamless integration and design, and that's absolutely true of the H2C. It even has 2 nozzles that can use different colored filaments to make these beautiful multicolored prints. If you've ever wanted to try your hand at 3D printing, I genuinely can't recommend Bambu Lab enough. They really set the bar for the industry. It's a completely seamless way to get into the world of 3D printing and at-home manufacturing. You aren't just buying a 3D printer, you're investing in a cutting-edge platform that receives constant firmware updates and new features. Their products just keep getting better. So just click the link at the top of the description to check them out, and in doing so, you'll be supporting the channel. Right now, Africa is splitting in 2, and I really do mean right now. As we speak, the continent is being pulled apart like this. It's just happening so slowly that your own fingernails are growing faster. This is the East African Rift, a 3,000-kilometer tear running from Ethiopia all the way down to Mozambique. The Somali plate is being pushed away from the rest of Africa at about 5 to 7 millimeters per year. Give it long enough and the sea will start to flow in. A brand new ocean will be born. As the crust stretches and cracks, fresh seafloor forms, and this is the first time we've ever caught that process in the act. And the seafloor is closer than you'd think. In the Danakil Depression, the ground sits around 125 meters below sea level, lower than the Red Sea right next door. All that's holding the ocean back is a thin ridge of rock, and it's broken before. Scattered across the desert, you will still find pieces of coral reef that have been left over from the last time that the ridge cracked and let the ocean pour in. There is a chance that the rift could stall and Africa never fully splits, but if it does happen, it'll take tens of millions of years. And while Africa is tearing open, just to the north, the exact opposite is about to happen. One day, the Mediterranean Sea is going to completely disappear. And it's already happened before. About 6 million years ago, the Strait of Gibraltar sealed shut and the Atlantic was cut off. The Mediterranean loses far more water to evaporation than it gets back from the rivers flowing in. So with the Atlantic gone, there's only one possible outcome. It dries out, its surface dropping by thousands of meters. What's left behind is a salt desert. The coastlines that we know today became the peaks of vast mountains, and most of the species living there went extinct. And then the basin refilled. The Atlantic flooded back through Gibraltar, and the sea level rose by more than 10 meters a day. The whole basin filled in just a few years. So around the same time that Africa is splitting open, Gibraltar will reseal. The Mediterranean will evaporate away again, and this time the entire basin gets crushed, throwing up a brand new mountain range stretching from Spain all the way to the Himalayas. Now let's go into the deep future. I'm talking 2 billion years in the future and see what the solar system might look like. From the outside, the solar system looks perfect. 8 planets moving around the sun like clockwork. But it isn't perfect. It's a finely tuned system balanced on a knife's edge, and the smallest planet could tip the whole thing into chaos. Mercury is the closest planet to the sun, and it's also the most controversial. If you take the solar system as it is today and simulate the next 5 billion years, most of the time, nothing happens. It looks pretty much the same. But if you run it again and again and again, around 1% of the time, Mercury's orbit breaks. Every orbit in the solar system slowly rotates around like the hand of a clock, and Mercury's happens to turn at almost the exact same rate as Jupiter's. If those two ever fall into sync, then Jupiter starts tugging on Mercury at the same point in every lap. It's kind of like pushing a child on a swing at the exact right moment, every single time. That tugging stretches Mercury's orbit longer and longer and longer until it crosses paths with the other planets. It could slam into Venus, fall into the sun, or maybe even drag Venus and Earth into the chaos with it. So why are we still here? Why hasn't this already happened? Well, you can thank Einstein. Mercury's orbit was actually the first real proof of general relativity. A tiny correction to what Newton predicted that almost perfectly matched what we can see. And it's that tiny correction that keeps Mercury's orbit just slightly out of step with Jupiter. Without relativity, Mercury goes unstable around 60% of the time instead of 1%. But don't panic. The earliest this could even start is nearly 2 billion years from now, long after the swelling of the sun has boiled away Earth's oceans and forced us to live somewhere else entirely. Back when I was in grade 8, I watched a Vsauce video on YouTube that's kind of like this one, where he talks about how the Milky Way and Andromeda will one day crash together and merge. And I remember actually feeling sad that I'd never get to see those beautiful views. But do you want to know a secret? That might not actually happen. Last year, a team reran the whole thing, 100,000 simulations feeding in every measurement we have from modern instruments, with all of their uncertainties accounted for, and the result was about a 50-50 chance that the collision ever happens at all. A coin flip. And it's all because of one thing. Not how fast Andromeda is falling towards us, but how fast it's sliding sideways across the sky. Andromeda is enormous, and it's definitely headed roughly our way. This is what it looks like in the sky, but if you turned up its brightness, it would look like this. That's how big it actually is from the Earth. Now, as it falls towards us, it's also drifting sideways like this, and measuring the sideways drift is incredibly hard. Using the Gaia spacecraft, scientists imaged Andromeda over about 4 years. One measurement says we drift past and miss it, and a newer one this year leans the other way, a 90% chance that we collide. But those two results are so close that they actually overlap. They agree more than they disagree. The drift is just sitting right on the knife's edge between hit and miss. So what tips the balance? A third galaxy. The Large Magellanic Cloud, a satellite of the Milky Way which is around 15% of our mass. It's gently tugging us sideways just off the collision course. Gaia is set to release a huge batch of new data this December, so hopefully we'll know soon whether Milkdromeda will actually happen. But even if it doesn't, in about 2.4 billion years, that same Large Magellanic Cloud will merge with the Milky Way anyway, lighting up the sky in basically the same way Andromeda would have anyway. Deep in the heart of our galaxy sits Sagittarius A star, our very own supermassive black hole. When you picture a black hole, you probably picture something like the one from Interstellar, violently devouring everything around it like a cosmic vacuum cleaner. But ours is asleep, and right now it's swallowing about a billionth of the energy it's actually capable of. That makes it the quietest black hole that we know of. Or so we thought. X-rays bouncing off gas clouds near the center of the galaxy tell a different story. Around 200 years ago, when Napoleon was still alive, Sagittarius A star flared up at least 1 million times brighter than it is today. We only found out in 2023 because that's when the light reached us. And if you look back further, it gets even stranger. 2.6 million years ago, just as our ancestors were starting to make their first stone tools, Sagittarius A star fired out a jet so violent it blew 2 enormous bubbles of material clean out of the galaxy. Each one is 25,000 light years tall, and they're still up there today, towering above and below the galaxy. One day it'll erupt like that again. But there's so much dust between us and the center of the galaxy that invisible light, the most violent thing our galaxy can do, is still too faint for even our best telescopes to catch. The night sky wouldn't so much as flicker, but if you pointed an X-ray satellite at it, it would blaze 15,000 times brighter than the entire Crab Nebula. These giant flares take millions of years, and they're basically impossible to predict. One could, in theory, go off tomorrow. But realistically, you and I will be long gone the next time our black hole decides to truly wake up. Look at this image. Basically, every single point of light that you can see is an entire galaxy. There are thousands of them here, all crammed into a patch of sky you could cover with a grain of sand held out at arm's length. There's around 2 trillion galaxies out there, and almost every one of them has already sent us its very last photon of light. We just haven't received it yet. But let me explain. The space between us is growing. The galaxies aren't really moving. It's dark energy that's stretching the fabric of space-time itself, faster than light can ever cross the gap to reach us. They'll keep shining, just like our Milky Way, but soon they'll simply be too far away and receding too fast for any more of their light to ever reach us. So one by one, they slip over the edge of what we can ever see. Around 100 billion years from now, about 7 times the current age of the universe, the sky finishes emptying out. In every direction, the galaxies will fade away. We'll see the stars in our own galaxy, but everything else beyond it is gone. It's just pitch black darkness. If the universe were already like that, and we launched Hubble or JWST to take those iconic deep field images, we would get nothing. Just pure black. There's nothing to see at all. To a civilization living in that era, the entire universe would be just their one galaxy. And there's literally nothing they could do to see past that dark barrier. The laws of physics just simply forbid it. And it gets even worse. The cosmic microwave background, the actual afterglow of the Big Bang, gets stretched away along with the galaxies. The future civilization would have no way of ever discovering that the universe began with the Big Bang at all. This is almost exactly what we believed just over a century ago, that our galaxy was the entire universe. But because we can see those distant galaxies, we were able to work out our true place in the cosmos. Honestly, I'm just glad that humans showed up this early in the universe. Any later, and the true beauty of the cosmos would have been impossible to discover. Now finally, let's go to the end of time. Long after the last stars die, after the very last black holes evaporate, after the universe has gone completely dark, there's one final bang. But what is it? It starts with a white dwarf, the dead, still glowing core that a star like the sun leaves behind at the end of its life. Wait trillions of years and it slowly cools down. Its light fades until it becomes a black dwarf, a frozen planet-sized diamond where a star used to be. Not a single one exists in the universe yet. We're just far too early. The first won't form for about another 1,000 trillion years. But deep inside that cold, dark lump, there's still a little bit of physics magic happening. The atoms are crushed together so tightly that they slowly tunnel into each other and fuse. No heat, just pressure. And piece by piece, this turns the entire star into iron. And iron causes problems. The moment enough of the core becomes iron, the star can't hold itself up anymore and pressure wins. So after floating through the dark universe, perfectly stable for trillions upon trillions of years, it collapses and then explodes. This happens 10 to the power of 1,100 years from now. There's basically no analogy that I can give you to help you understand that number. That's a 1 followed by 1,100 zeros. Take the entire age of the universe today, all 13.8 billion years, and then relive it. Then do it again, and again, and again, and again, once for every single atom in the observable universe. That's still only 10 to the power of 90 years. You've barely even started. This will be the very last light the universe will ever make. One final flash in perfect darkness, with nobody left to see it. The very last event before the end of time itself.